Thank you, Professor Roy, and the organizers for the opportunity to share some of the facts and phenomena. So I was actually informally requested to say something about ancient Indian mathematics, but in the context of colonial and post-colonial period. But time is very short. So what I have decided is to give some representative examples, and I certainly won't be comprehensive. So examples of scholars who have highlighted some aspect of ancient Indian mathematics and the response, how much it had percolated in the minds of the leading thinkers of the time. Again, through examples, and just one example each. So, as in the case of what Ramasubramanian highlighted, that in 19th century things started happening. So he talked about calculus. My focus would be more on algebra. So English translations of books of Bhaskaracharya. You see, among ancient Indian mathematicians, probably the most well-known name is Bhaskaracharya, because his books came up first. So they were translated in early 19th century by Strachey and Taylor. But the book which perhaps had maximum impact in early 19th century in generating some awareness about the richness of post-Vedic Indian mathematics was the book by Kolbrook, Algebra with Arithmetic and Mensuration from the Sanskrit of Brahmagupta and Bhaskara. I am preserving the title, preserving the spelling which Kolbrook gave. So this was 1817. It's sad that a few years ago, 200 years passed about this landmark, and there was no celebration in India or Kolkata. Now, this book contained a translation of the mathematics books of Bhaskaracharya, namely Lilavati and Bijganita, and in addition, 2 chapters from Brahmagupta's magnum opus, that Brahmasphuta Siddhanta. It has 24 chapters, the 2 mathematical chapters, one on arithmetic and mensuration, Ganitadhyaya, and one on algebra, Kutakadhyaya. So these were translated. That's one part. The other thing is that this book contained a long preface on the distinguished features of the text. And what is more important is that this preface was reproduced by him in compilation Miscellaneous Essays. Now, this his book, this Algebra with Arithmetic and Mensuration, etc., that would be kind of for a specialist, technical. So, in itself, it might not have drawn the attention of all scholars. But his preface being reproduced in Miscellaneous Essays, that must have caught the attention of general scholars. And these are discussions on the salient features of the mathematics of Brahmagupta and Bhaskaracharya. So I'll just give one quotation from that essay, that one of the features of Indian algebra was that the general methods for the solutions of indeterminate problems of first and second degrees, in which they went far, indeed, beyond Diophantus, and anticipated discoveries of modern algebraists. Mind you, the phrase, anticipated discoveries of modern algebraists. Please remember this phrase, because this would be important for the next 5 minutes. And these are the kind of expressions which irritate modern intellectuals. So let me just illustrate now from ancient Indian mathematics justification for this phrase. So you know that linear equation like ax minus by equal to c, where a, b, c are integers, have to be solved for integers. That is the problem of integer solution of linear equations. And what Kolbrook knew is that Brahmagupta had given the method for solving it. Of course, even earlier Aryabhatta had given, but by the time of Kolbrook, Aryabhatta's work was not discovered. Therefore, I am including both the names. And what is now called Chinese remainder theorem is also occurs in the work of Aryabhatta and Brahmagupta, that to find an integer which when divided by given integer b1 leaves a given remainder r1, and simultaneously when divided by b2 leaves remainder r2, and so on. Now, this method of Aryabhatta and Brahmagupta appears in the work of Bashe in early 17th century. So, more than 1100 years after Aryabhatta and subsequent European algebraists. This illustrates the divide and conquer strategy in modern computer science. This resembles and contains the seeds of the idea of the celebrate there is a typo here, principle of descent of Fermat. So I don't know how the word blue had come up. I think I meant to write Fermat and try to color it in blue. I think this. And this has applications. It is fundamental in modern coding theory. So now you see the justification of Colebrook's phrase. And then more significantly, there is something called Brahmagupta-Pales equation. Actually, it was called Pales equation. Nowadays, it is being called Brahmagupta-Pales equation. This is solve in positive integers, equation nx square plus 1 equal to y square. And this is very important in modern algebra and number theory. And n is a non-square positive integer. So it is Varga Prakriti, square natured, because if n is not a square, then nx square cannot be a square. But try to make it a square by adding 1 or a small number. So that's the. Now this problem was taken away by Brahmagupta in 628 and partially solved, and then complete solution was given by a mathematician named Jayadev before 11th century and Bhaskaracharya in 1150. So again I'm giving two names because Bhaskaracharya's work was discovered first. So when Kolebrook is not of course referring to Jayadev, he is referring to Bhaskaracharya. Jayadev was discovered only in 1954. And Hankel said about Bhaskaracharya's Chakravala method, it is beyond all praise. It is certainly the finest thing achieved in the theory of numbers before Lagrange. When is it being said? 1874. Now, the same problem of Brahmagupta Bhaskaracharya was stated by Fermat as a challenge 1000 years after Brahmagupta. And about it, one of the giants of 20th century mathematics, Andre Weil, says, what would have been Fermat's astonishment if some missionary just back from India had told him that his problem had been successfully tackled there by native mathematicians almost 6 centuries earlier? This is statement of Andre Weil. Now, just let me quickly summarize the history of the equation. This was first taken up by Brahmagupta in early 7th century, and the complete solution was given by Jayadev before 11th century. And you can see the intricacy of the problem by seeing that what is the smallest positive integer satisfying 61x square plus 1 equal to y square. And this is stated with solution by Bhaskaracharya. I mean, he gives a general method, but also this special case. The same problem is comes up by Fermat. He sets it as a challenge to inspire mathematicians to do number theory. Brownker gives the solution. Wallis gives an exposition on it. Then 1 century after Fermat, Euler gives theorems on the theory. He develops a theory of continued fractions, which gives a broad framework in understanding the equation. So this is put in a much broader perspective, but Euler could not prove all the theorems that he stated. The complete proofs were given by Lagrange in 1768. Now, so this is, as far as mathematics is concerned, you see Kolebrook had mentioned about it, had alluded to it. Now you see somebody, a thinker outside the world of mathematics or even history of mathematics, in passing, in his essays on Indian culture, Sri Aurobindo mentions in passing in 1919. So year is significant because this is before our Vibhushan Datta comes into the picture. That it is very surprising that he had this insight in 1919, that especially in mathematics, astronomy and chemistry, the chief elements of ancient science. So let us focus on mathematics. She means India, discovered much and formulated well. And again you see that Kolebrook's phrase, anticipated by force of reasoning experiments some of the scientific ideas and discoveries, anticipated, which Kolebrook had said 100 years earlier. Which Europe first arrived at much later, but was able to base more firmly by her new and completed method. Now you just see that Brahmagupta Bhaskaracharya between 628 and 1150, they anticipate things which Europe developed from Fermat to Lagrange much later, but of course Europe, that means Lagrange, Euler and Lagrange base it more firmly and more completely. So this awareness is there in Savant, who is outside mathematics. Sri Aurobindo's areas were in poetry, literature, history, but you can see that how accurate. In fact, I have not found a better abstract for this history. And then, a neglected jewel of Calcutta University. Calcutta University celebrates its stalwarts, but they never mention about Vibhutibhushan Datta, who was as great a historian as, let us say, Jadunath Sarkar and Ramesh Majumdar in his specialization. So, since time is running out, I just mentioned that his papers, numerous papers in the 1920s and 30s, a wealth of information and insights for anybody interested in this topic. And he is a valuable source book called Datta Singh, History of Hindu Mathematics. Part 1 is on arithmetic and part 2 on algebra. And in addition, for those who would like to have information and insights on the mathematics of the Vedic time, don't confuse it with the book Vedic Mathematics that is in the market. The actual mathematics of the Vedic time, the book is Datta's Science of the Sulva, published by Calcutta University. And you can see the review of that in 1934 by a top historian of science of those days, that Dr. Datta's volume is one which should be in the hands of every student of the history of mathematics. It is serious in purpose, presents arguments pro and con fairly and fully, and contains many original points of view and scores of exact references to authorities and texts. So much information regarding the Sulva. So Sulva is about the mathematics of the Vedic time. Has not been earlier available in any readily accessible English source. And now what Datta says about his assessment of the mathematics of the Vedic time. How great is the science? So he is alluding to Kalidas actually, in a Kalidas style. How great is the science which revealed itself in the Sulva, and how meager is my intellect. I have aspired to cross the unconquerable ocean in a mere raft. This was Datta's tribute. And now Datta is writing in the 20s and 30s, and the book is published in 1935 and 38. Now you see the impact on a thinker who is outside the domain of mathematics and history of mathematics. Before that, just to give you an idea about how rich that mathematics is, not just go by Datta's statement, the Pythagoras theorem occurs in Bodhayan, that all of you know, in the form of a statement about the diagonal of a rectangle, and it is applied in constructions, and that is so sophisticated that Bodhayan's construction of a square, which is equal in area to a rectangle, it gives an exact construction. There is no measurement or approximation involved, and it has what is called geometric algebra. The algebraic formula is expressed in geometric form. And this is their greatness, that they invent mathematics algebraic in spirit and substance much before the genesis of formal algebra, which makes the Vedic savants greater as algebraists. But before formal algebra was formalized by Brahmagupta much later, they do mathematics which is algebraic in spirit. And Seidenberg says about this construction, which I'm just going to indicate briefly, this is entirely in the spirit of the elements of Euclid. Indeed, I would say it's more in the spirit of Euclid's elements than Euclid's elements itself. Now, I just to give you an idea about the sophistication, so this is the rectangle, and you have to draw a square equal in area to this. So this is A and this is B. You complete the square. This is B. So this part is A minus B, bisect it. So this is A minus B by 2 and this is B. The whole total is A plus B by 2. So you draw an arc. So this is A plus B by 2, and then you extend it. So this is the point. So this, they say, is the desired length. So this is A plus B by 2 and this is A minus B by 2. A plus B by 2 whole square minus A minus B by whole square is AB. So you can just see for yourself, just don't go by the words of Datta, how sophisticated the mathematics of Vedic time was. Now its impact. Jawaharlal Nehru in Discovery of India says, so since time is short, I will just read out only parts of it. The origins of geometry, arithmetic and algebra in India go back to remote periods. And it is very touching that somebody who is completely outside mathematics, reading Datta Singh, and he didn't read Datta, he read only Datta Singh. Datta Singh's History of Hindu Mathematics. He says there was some kind of geometrical algebra. He goes on to, he even uses the phrase geometric algebra. I mean, coming from Nehru, it is really very interesting, because he was not a mathematician, used for making figures for Vedic altars. And he gives examples also, which is given in Dutta Singh about converting. So the problem that I'm saying, he talks about the converse problem of converting a square into a rectangle, which is like solving ax equal to c square. Then he mentions about many other things. So again, he emphasizes, it is clear that the beginnings of arithmetic, algebra, and geometry were laid in that earliest period. And he says, 10 formed the basis of enumeration in India even at the time of Rig Veda. And Jawaharlal Nehru acknowledges the books of Dutta Singh. And all this thing was before independence in 1944. So he read Dutta Singh and infused it seamlessly in his discovery of India. Now we have to say something about post-colonial period. And about post-colonial period, probably the most famous thinker is Amartya Sen. Amartya Sen writes in the Argumentative Indian, as it happens, despite the richness of the Vedas in many other respects, there is no sophisticated mathematics in them. So at one stroke, all this Datta and whatever Nehru, whatever you have heard, all these things are dismissed at one stroke of a sentence. There was, however, but this is the balanced approach. There was, however, much of both in India in the first millennium AD. That means I am considering that Aryabhatta and Brahmagupta were great. Now you concede that there was no mathematics during the Vedic period. And if you do that, then this is intellectual execution. These contributions were early enough. That means the contributions of early Aryabhatta and Brahmagupta were early enough in the history of mathematics and science to demand respectful attention. But the BJP created, he uses the word BJP, I am not using it. BJP created with little reason and even less evidence to place the origin of some of these contributions to the much earlier Vedic periods. Take this as axiom. The logical conclusion is Vibhushan Datta is BJP and Jawaharlal Nehru is BJP. Logical conclusion. And he goes on to say in the Indian Science Congress, those who are looking for the origin of Indian mathematics in the Vedas would be completely barking up the wrong tree. So who were barking up the wrong tree? Vibhushan Datta and Jawaharlal Nehru. And it is not an isolated aberration. In 21st century in the media, I am quoting statesmen, not even Anandabajar, a sober newspaper. There's a quiz. In 2002, the BJP says that many scientific theories originated in India. What have the re-Christian Bauddha and done? Pythagoras theorem. This is quiz published in the Statesman. And a professor in political science, Subrata Mukherjee, writes about this, that, you know, in those period, they were saying that ancient Indians had excelled even in the natural sciences, mocking at it. A position that declined subsequently, as if that is good. So the impact of all this is very serious because I am an active in this history of mathematics. There is now an, it is like, in cricket, sledging kind of thing, that when a batsman comes, there is a whole lot of fielders around him. There's an inhibition in highlighting ancient Indian mathematics. Meaning, if I talk about Indian mathematics, then people may think of me as BJP, etc. And if I hate BJP, then of course I would not like that. But even if I like BJP, political thing is something which is meant to be confidential. So I would not like to be known as BJP, whether I hate or like it. And therefore, I'll be inhibited. And this is reflected in the writings of even those who get Padma Vibhushan. When they say a nice thing about Indian mathematics, they try to balance it by saying something, not so nice or derogatory, which may not have any base, just for earning credibility. And most are adopting an attitude of cultivated ignorance. This has to be addressed by a new Society for the History of Science. And and this is interesting that Amartya Sen himself describes the phenomenon of which he is a part, that those who these people are suspicious of what may even look like a glorification of India's past, and therefore Indian thing is not highlighted. So anyway, I'll just take 2 minutes to just draw your attention to something that in spite of the work of Colebrook and Dutta, they were very, sincere workers. But you see, Dutta wrote in 1930 and modern algebra started only in 1930. So certain things which ancient Indians done was not realized. Its true significance was not realized by Colebrook or even Dutta. Just to give you one instance, that where the Brahmagupta's work lay, that in a research monograph of 1990, you look at This chapter 5 is titled Also Sprag Brahmagupta. Chapter 5 is titled Also Sprag Brahmagupta, and Brahmagupta's verses are quoted because Brahmagupta's result is the foundation of that chapter. It goes there. Look at what Manjul Bhargav said when he got the Cole Prize in the acknowledgement, that he built on the ideas of the predecessors. The paper cited about built on ideas that go way back, to, starting with the mathematical works of Brahmagupta, Gauss, Dirichlet. Now, you look at the names mentioned and you see an anomaly. Brahmagupta is 628, Gauss is 1801, Dirichlet is 1838. So when Manjul is praised for his higher composition laws, he acknowledges Gauss and subsequent mathematicians, but before that makes a mention of Brahmagupta. Now, this aspect would not have been realized by Colebrook or even Dutta, because modern algebra itself starts in 1980. Modern abstract algebra that is taught at college. And I'll just tell you that Brahmagupta's composition law, which is called Bhavna in Indian mathematics, and now in tribute to that, there is an excellent mathematics magazine named Bhavna. I'll just give you, if you study abstract mathematics, then in the BSc level, you study abstract structures like groups and rings. At the MSc level, you start associating objects with, associate abstract subjects to mathematical objects. Only in special research, specialized research, that too only for some people, not for all mathematics researchers, is the idea of constructing binary composition on an important set. And Brahmagupta, who was the founder of algebra, soars to the, bypassing this, the first two layers, soars up to the really top layer, that constructing binary composition, which is central activity of modern mathematics research. This is something which you will not get even among the best historians of, writings of the best historians of mathematics 100 years ago. So this is something to be noted, but this is 7th century work. In a talk, Manjul Bhargav said that what Brahmagupta did in 600 just blows your mind. That much impact you will not get even from Dutta. So, thank you.